Okay, hello students. Last time we have done errors and the propagation of errors. Today we will take up some of the numericals on the topic errors. As we have done the 5 formulas which correlates the different physical quantities x, y and z with the different relations among themselves. Now let us take up the first numerical, this one. The statement of the numerical is: consider a rectangle having length 20 plus minus 2 meters and breadth 5 plus minus 1 meters. Find perimeter and area of the rectangle. Clear? So we know that the expression for the perimeter is P, that is a perimeter, is equal to 2 times the sum of length and breadth. Clear? The length is represented as 20 plus minus 2. The first term over here before plus minus is the length, is the physical quantity itself, and after plus minus is the possible error in the measurement of length. So that will be represented by delta L. Similarly, in case of breadth, the magnitude of the breadth before plus minus is the breadth itself, and after plus minus is the possible error in the breadth, that is represented by the delta B. Now we have the formula for perimeter, that is 2L plus B. Length is 20, breadth is 5. So this will come out to be 2 times 20, that is length, plus breadth is 5. 20 plus 5 is 25, is to 2 is 50. So the perimeter will be 50 meters. Now this is the first formula. If you look at the formulas of the errors, that is z is equal to x plus y, x minus y, z is equal to x into y, z is equal to x upon y, z is equal to x raised by n, y raised by m. So this comes in the category of the first formula, z is equal to x plus y. For that the error formula is delta z is equal to delta x plus delta y. So that will come out to be, if we apply that formula over here, this will be delta p is equal to 2 times delta L plus delta B. Now putting up the values of delta L and delta B, we will get 2 plus 1 is 3, is to 2 is 6 meters. So as we have written length as L plus minus delta L, breadth as B plus minus delta B. Similarly, we have to write the perimeter as P plus minus delta P. So if we put up the values, that will come out to be 50 plus minus 6. This is the error. This is the perimeter of the given rectangle with this length and this breadth. One more thing we can discuss over here is, if it is given in the question that find the fractional error in the measurement of perimeter. For that one, fractional error is equal to delta P, error in the given quantity, upon actual value of the given quantity. So it will be delta P is 6 and P is 50. So this is the possible fractional error, and you need to remember that fractional error always comes out to be less than 1. Clear? 6 by 50 is less than 1. Now we can also find the percentage fractional error. This fractional error is also called relative error. They can ask you about fractional error or relative error. Both are the same things. Clear? So percentage relative error or percentage fractional error is delta P upon P into 100. You just have to multiply this with 100. So this will come out to be 6 by 50 into 100. So this will come out to be 12. Clear? So the perimeter of the given rectangle is 50 plus minus 6. Fractional error or relative error is 6 by 50. Percentage relative error or percentage fractional error is 12. You don't have to say percent over here. Okay? Then is finding the area for the same rectangle. We know that the formula for the area is length into breadth. So this will be 20 into 5. That will be 100. Area will be meter square. And this is the third formula, z is equal to x into y. For that the error formula is delta A by A is equal to delta L by L plus delta B by B. Putting up the values of delta L, L, delta B, B and the value of A, which is 100, we'll get this expression. Taking the LCM, we can cancel out this 2 with 20. This will come out to be 10. 1 by 10 plus 1 by 5. Taking out the LCM of these two, that will be 10. And this will be 3 over here in the numerator. Taking this 100 along this side, that will make it 30. So the area comes out to be A plus minus delta A. That will be 100 plus minus 30. Again, if I have to find the relative error, that will be error in area upon area. So that will come out to be 30 by 100. Just look at again, it is less than 1. Percentage relative error, that will be 30 by 100 into 100. So this will come out to be 30. Now moving on to the next numerical. Suppose we have a rectangle of length 30 plus minus 3. So this 30, as you know, that will represent length. 3 will represent possible error in the length. And breadth is 10 plus minus 1. So breadth is 10 and this 10 is possible error in the breadth. Now perimeter, that will come out to be, if you solve in the similar manner, that will come out to be 80. This question you have to solve yourself. This will be your answer. Perimeter will be 80 plus minus 8. In the similar senses, area will be 300 plus minus 60 meters square. Clear? Now, write on the next numerical. Find the area and volume of a sphere having radius 30 plus minus 3 meters. Now, radius is given in the question. So, radius is 30 and possible error in the radius is 3. This is the value of r, this is the value of delta r. We know that the expression for the area of the sphere is 4 pi r square. Clear? For the convenience of the calculation, I am taking pi to be 3 only. Otherwise, this value is 3.142 or you can say 22 by 7. But I am taking this value to be 3. So, if I put up the values 4, 3, r is 30, 30 square. 30 square is 900 and this 4 is to 3 is 12. 12 nines are 108 and 2 zeros over here. So area will come out to be 10800 meters square. Now applying the fifth formula of errors, that is z is equal to x raised to power n, to this expression of area, that comes out to be delta z by z is equal to, this power will come in front and these constants, they won't remain in the error formula. So you're left with delta a by a is equal to 2 delta r by r. So delta a is this much. We will put up this value over here, 2. Delta r is 3 and r is 30. Clear? Cancel out the common factors. You left with delta a comes to be 2160. Clear? Therefore, the area will be a plus minus delta a by, that will be 10800 plus minus 2160. That will be the area of the sphere. Similarly, we can find the volume also. The formula for the volume of the sphere is 4 by 3 pi r cube. Putting the value of pi as 3 for the convenience, it will be 4 by 3 into 3 into 30 cube. Cancel out 3, you are left with 4 into 27,000, which will come out to be 108,000 meter cube. Volume, again applying the fifth formula for the errors, that is z is equal to x raised by n. Delta v by v will be 3, power will come in front, delta r by r. Putting up the values, 3, delta r is also 3 and r is 30. 3 and 30 will get cancelled out. You are left with 10 over here. This 0 will get cancelled out with 0 over here. And multiplying this 3 with 10800, you will get 32400. So error, possible error in the measurement of volume will be 32400. Hence the volume will come out to be v plus minus delta v. That is 108,000 plus minus 32400 meter cube. Clear? You can try at your own. For this numerical, find the area and volume of a sphere having radius 20 plus minus 2 meters. If you solve this one yourself, you will get the answer of area as 4800 plus minus 960 meter cube, and for the volume is 32,000 plus minus 9600 meter cubes. This you can solve yourself. Next, moving on to the other numerical. If we have the numerical of this shape, say, find the percentage error and the physical quantity x, which is given by the expression, this expression, in terms of a, b, c, d. Clear? Now a, b, c, d is related with the x by this relation. Say x is equal to a square b cube by c root d, such that a is equal to 10 plus minus 1, b is equal to 20 plus minus 2, c is 30 plus minus 3, d is 40 plus minus 4. Where this 10 will represent a, physical quantity a, and this 1 will represent possible error in the measurement of a. Similarly, b plus minus b, c plus minus c, d plus minus d. Clear? Now first, to calculate the value of x, directly put up the values of a, b, c, d, which is 10, 20, 30 and 40 over here. Suppose if I square, cube, take the square root, multiply with 40 and divide these all and get the answer. I am supposing this answer to be 50. Clear? You can calculate it yourself, but I'm supposing that after this calculation the answer comes to be 50. Clear? Now applying the error formula, what you have to do is the powers of the physical quantities, just like a, b, c, d, that will come in front. For example, in this case 2 will come in front and we'll get the relative error of a, delta a by a, plus 3 will come in front, delta b by b, plus, because error के फॉर्मूले में कभी भी नेगेटिव नहीं आएगा, this you need to remember. Clear? This c root means c raised to 1 by 2. 1 by 2 will come in front and you will get delta c by c plus delta d by d, like this. 2 delta a by a, 3 delta b by b, half delta c by c, delta d by d. Now put up the values of delta a, b, b, c, c, d, d from here and solve them. After solving them and taking this the value of x, which comes to be, we suppose to be 50 along this side, you can solve it like this, taking the LCM over here, cancelling the common factor. This will come out to be 32.5. Clear? So finally we can write the physical quantity x as x plus minus delta x. So it will come out to be 50 plus minus 32.5. So in this way we can solve the numericals related with the errors. And you can have one numerical of the similar type like this, which you can solve yourself. X is given by a cube b square by c root d, such that a is equal to 10 plus minus 1, b is equal to 20 plus minus 2, c is 100 plus minus 10, and d is 30 plus minus 3. Clear? You can solve this one yourself for your practice. Thank you and have a nice day. Stay safe.